things. We'll start to use the same words as Monday and Tuesday and add some more vocab to it. And I know you guys aren't huge lover of vocab, but we're going to continue to use those words. So today we're going to talk about independent variables and dependent variables, but we're going to link it to things we already know. Independent variables are your chosen values, the numbers you want to choose, the input, the cause, the x values. And on Monday, we learned the x values are part of the domain or range. Domain. Okay, so linking these all together, independent variables are x values and the domain. Independent are x values and the domain. Dependent variables depend upon independent variables. They're the outputs, the effect, the y values, and are members of the range. Dependent variables, y values, range. Okay, so what's going to happen is, as you see in the next two problems, they're going to give you a graph and then they're going to give you a table. And it's going to ask you to identify the independent and dependent variables. On Alex, they're drop-down menus. Obviously, I can't give you a drop-down menu. The graph below shows how the cost to mail a package depends on the weight of the package. Identify the dependent and the independent. Okay, so let's do this. Dependent, we're going to label it, and then independent. Now remember, dependent is the range. Look at the top. Dependent is your y values, is your range. On your graph, how do you know which of those is the range or your y values? Yeah. This is the x-axis, but for dependent, we want the y-axis, right? So our dependent variable is right here, the cost to mail the package. Leon is absolutely right. Look at the labels on your graph. So your dependent is the cost to mail the package. The independent is, very good, the x or the domain, the weight of the package. So on a graph, you're taking the labels off your axes. X-axis independent, y-axis dependent. Now we're going to talk about in a table. Bob makes necklaces for his job. The table below shows how the number of hours he worked influences the number of necklaces he made. And here's our table. Identify the dependent and the independent variables. Dependent, y, range. What is the label on our y's in this? Number of necklaces. How did you know that, Bryce? Y. Number of necklaces made. Dependent, number of necklaces made. Independent is our input, our x values. Number of hours worked. Biggest thing with this, you have to read. You have to read, okay? So right now, you're going to do the bottom one all on your own. On both of these, I want you to tell me what the independent and the dependent variable are. Yep. You need the independent and the dependent variable. Write your labels. Oops, sorry, I stabbed you with it. I'm sorry. Okay, you have two different ones, so make sure you answer the graph and the table. You're supposed to be doing these two problems. You guys are supposed to be answering the bottom two problems. Don't worry about what else we're doing today. Remember, independent are your X, your domain. Dependent are your Y and your range. Ooh, I love it. Young just put up an X and a Y next to these words so she remembered which was which. That's a great idea. That's a great idea, Caitlin. Read carefully. Pay attention to the order Miss Hoff wrote them in. Pay attention to the order Miss Hoff wrote them in. Okay. We said independent variable is our input, or in other words, our X values. Miss Hoff wrote these opposite of the last ones to make sure you're paying attention. Independent is X. In this graph, somebody raise your hand and tell me which one of those is your independent. Bryce? Independent, yep. Very good. Number of hours studied. That is our X. That is our X. Dependent, Petro, is test score. Dependent is your Y. Test score. Everybody on your own, double check this one. Independent is which letter? Y. X. Dependent is Y. Pay attention. Pay attention. Ms. Hoff swapped the order on these, so you got to pay attention. Dependent is Y. Caitlin? Independent. Your X. What'd you write? Excellent. Weight of package in pounds. Addison, Y dependent is? Very good. Cost to mail package in dollars. No, just write it down. Okay. Cost to mail the package in dollars. Here's where they're going to trick you guys, just like Miss Hoff did. Up here, I wrote dependent, then I wrote independent. Down here, I wrote independent, then I wrote dependent. You have to pay attention which one they're asking you for first. Independent X, dependent Y. Independent X, dependent Y. And if you forget, maybe you go and underline this up in the definition so you don't forget. Okay? Independent X, dependent Y. All right, the second part of what we're doing today, we're going to connect independent and dependent variables with graphing equations. Independent variables are your X values, and dependent variables are your Y values. We're going to make a table to keep your information organized. You need at least 3 points to graph the line. So today we're going to talk about graphing again, and I'm going to show you a different way to do it. Okay, we're going to talk about a different way to do it. I actually want to graph the bottom one first. So I provided you a table. You get to pick your x values, and we're going to talk about choosing wisely. We're going to plug it in and follow our order of operations, and you're going to calculate your y, which will give you points. So here's our equation right here. In my table, I'm going to write that in the top, negative 2x minus 5, because that's what I'm going to plug it into. Bottom. Now, you get to pick values of x to plug in. What is the easiest number to plug in? 1. Okay, let's pick 1. What that means is we plug it in for x. So negative 2, and then in parentheses 1 minus 5. Now, do I multiply or subtract first? There's no division in this. Do I multiply or subtract? Why multiply? Because of PEMDAS. Yes, there's parentheses, but it's not inside the parentheses. There's not any exponents, so we multiply. So first we need to take, whoopsies, negative 2 times 1, which is negative 2. And then I need to subtract 5, which is negative 7. So the point we just created in our x comma y, what was the x value we plugged in? 1. And the y value we calculated? Negative 7. Does that point fit on your graph? Okay, this is where some of us struggle. We have to plot this point. 1, negative 7 is a single point on the graph. 1 is my x, so I go to a positive 1. Negative 7 is my y, so I go all the way down to negative 7. I put one single point on my graph. Now, somebody tell me another easy number to plug in. 0. 0. So if I plug in 0, negative 2 times 0 minus 5, what do I do first? Multiply. Negative 2 times 0? 0 minus 5? Negative 5. What was the x? 0. And the y? Negative 5. Now put that on your graph. 0 on your x, negative 5 on your y. Nope, we got to get 3 points. 0 on your x, don't go left or right, just go down 5. Now, I heard somebody else say another easy number would be 2, right? Okay, so let's plug in 2.
Negative 4.
So we're going to take negative 2 times 2 minus 5. First thing I should do, multiply. Negative 2 times 2 is negative 4. Now be careful here. Minus 5. Negative 4 minus 5. Negative 9. 2 comma negative 9. Graph 2 negative 9 on your graph, or plot 2 negative 9 on your graph. Okay. This, you go 2 to the right and down 9. Now, if you've done this correctly, those points should all match up where you could easily draw a line through them. Agreed? Okay. So on Alex, then you'll easily draw a line through those points. Now, sometimes you might pick a number to plug in and it doesn't fit on your graph. Then you have to pick a different one. They have to fit on your graph. You get to pick. You know what number Miss Hoff's always going to pick? 0. I'm always picking 0. And I'm going to show you why I'm not going to pick 1 necessarily all the time. Okay? Let's go to the top. What's the equation we're plugging into on this one? Negative 2/3 x minus 2. Now, Miss Hoff says she's always going to pick 0. Can we plug 0 in first? Okay. I'm always, and I strongly encourage you to plug in 0 as well. Every single time. Negative 2/3 times 0 minus 2. Are we going to multiply or subtract first? Multiply. Always multiply. Negative 2/3 times 0? 0. That's why Miss Hoff likes to pick it. 0 minus 2? Negative 2. So my point is? Very good. And Tone pointed out this is an easy one to graph because you don't have to go left or right. Agreed? 0 on the x. You're not going to move left or right, but you're going to go down 2. Now, a lot of you wanted to pick 1, and Miss Hoff said, I wouldn't always pick 1. I'm going to show you why. Okay? So if I pick 1, negative 2/3 times 1 minus 2. Any number times 1 is the number you started with. So negative 2/3 times 1 is negative 2/3 minus 2. We all hate fractions, yes? So do not pick that. Okay, make yourself a note. If there is a fraction, if there is a fraction, pick multiples of the bottom number. Or in other words, the denominator. Of just the denominator. I'll talk about what that means in a minute. First off, what does the word multiples mean? What's a multiple of 4? 4, 8, 16. See what I'm saying? Like 4 times 1, 4 times 2, 4 times 3, 12. Okay? Where's the denominator located? The bottom of the fraction. So in our problem, what's our denominator? 3. So we want to pick multiples of 3. First off, pick 3. Pick 3. So let's plug in 3. Negative 2/3 times, can I write 3 over 1?
Yes.
Okay, and then minus 2. Why does Miss Hoff say to pick 3?
Because you can minus out.
They cancel. A lot of you are like signaling to me they cancel out. They cancel out. These cancel out, and you're left with negative 2 minus 2, which is a negative 4. So you're at 3, negative 4. Go plot that point on your graph. 3, negative 4. Three to the right, and then down 4. So if I say a multiple of the denominator, 6 would be one to plug in. Very good. I'm impressed you guys remember what the word multiple means. Okay. Negative 2/3 times, are you okay if I put 6 over 1?
No.
Minus 2. Okay, what happens on this one?
You can 3 divided by 6.
Yep, so 3 becomes a 1, 6 becomes a 2. So then negative 2 times 2 is negative 4 minus 2 more. Negative 6. You're subtracting, not multiplying. So you'd have 6 -6. 6, -6. Do they line up? They look like you could easily draw a line through them. Which number are you always plugging in? Always plug in 0. If there's not a fraction, I'm absolutely picking 1 and 2 to plug in, right? If there's a fraction, that's where we have to pick the multiples. Independent is your which letter? X. Dependent is your Y. On these problems, you don't have to show me any work, right? On these ones, you're going to have to show me how you came up with these points. Paper on the back desk with the grids. The rest of the hour is yours to work.